Hello everyone, I'm Shivnath Babu, co-founder and CTO at Unravel. Welcome to my talk on Dataops for the new data stack. In addition to being co-founder and CTO, I'm also an adjunct professor of computer science at Duke University. My background is in building data platforms. I've built multiple platforms as well as researched and taught about data platforms for more than 20 years. I'm very excited to be presenting here. In fact, I'm even more excited to see how more than 100 enterprises have joined us at the Dataops conference. Many of you are building or you own very innovative data products. In fact, the data products that you're building take different kinds of data, be it very structured, relational kind of data to semi-structured JSON kind of data, or unstructured videos and streams of speech and convert them into data products. And the path that is taken to do this is very standard. First, the data has to be captured, and that might be in the form of batch ingestion of data, or it could be real-time streams that are ingested. And this data is usually captured in a data warehouse or a data lake, from where advanced analytics, BI, machine learning, and these kind of operations are performed on the data. They may be orchestrated periodically or on demand. Batch processing of large chunks of data is very common and often used in building machine learning models. Or this data might be processed in real time as it streams in. The result of all of this analysis is usually published to consumers, and this can take many forms. Sometimes the data is actually made available in a real-time interactive data store, or it might just remain in the lake or in the warehouse. And the metadata might be published in the form of a catalog or a feature store. And this is how a lot of these products actually get very rich insights that are generated based on the data and then delivered to consumers. And many industries, from retail and e-commerce to manufacturing to financial and fraud detection to insurance, healthcare, and as Kunal was speaking in the morning, even the entire COVID vaccine drive was really fueled by data analytics. And this entire process of building data products is pretty much what we can call a data pipeline, where the data starts from these sources and eventually becomes products by going through a very interesting pipeline that has many different components. These pipelines used to be pretty hard to build, but over the last few years, a new data stack has emerged that makes it easier than ever to create data pipelines. For example, if you take the batch ingestion of data, which might involve orchestration of different tasks, managing a lot of different kinds of dependencies, and making data available at the right place at the right time. Solutions like Airflow, Fivetran, Azure Data Factory, AWS Data Pipeline, Google Dataflow, all of these make it much easier than ever to run these batch ingestions. Or take the other extreme, real-time stream processing and real-time apps, which are extremely critical in a financial or in a healthcare domain. In fact, when I was a student doing my PhD, I spent 6 years building a data stream processing system. But you don't have to do that today. Today, you just use a Kafka or a system like a Fluentd to ingest logs, process them in Spark Streaming or Flink, store the results in a Druid, and there you go, your real-time app is ready. If you take more advanced analytics use cases or BI, where a lot of different kinds of data might be captured in a data lake, solutions like Databricks or Delta Lake with Spark for data processing, or solutions like Presto with all the rich and fast SQL analytics capabilities, make this process of building BI dashboards or doing advanced analytics super easy. And if data lake is not your cup of tea, and you're more of a data warehouse person, then we have solutions like Snowflake or Redshift or Azure Synapse or Google BigQuery to make the process of extracting insights from data stored in the warehouse, usually through batch processing and sometimes through advanced transformations like what you can do with DBT, the data build tool. All of this can drive rich BI and advanced analytics. For the more complex and sophisticated use cases which involve machine learning, there are a lot of new solutions like TensorFlow or PyTorch or Amazon SageMaker. Or to make the data easy to discover, we have solutions like Data Hub. There will be a talk on Data Hub today at the conference, or Amazon. And to publish and consume the rich features that are generated based on this data, they new solutions like Tecton. So overall, as you see, even though the data pipeline has many different types of stages, a lot of new solutions have emerged to make it easy to construct these pipelines. But does writing the hello world for your data pipeline make it very easy to test and manage and do the entire data ops? Unfortunately, no. And as Kunal mentioned in his keynote in the morning, this is where the curse of the 3 Cs kicks in, namely complexity, crew or lack thereof, or coordination or lack thereof. Right? As you saw, the pipelines tend to have many different kinds of modules, and it might be different systems that are getting stitched together in the data pipeline. And those are things that add to complexity, especially because it's not easy to find skilled engineers or data scientists or operational staff to manage, monitor, troubleshoot, tune, and fix these pipelines. And a lot of the time, pipelines involve different team members handling different parts of the pipeline. Maybe there's a ingestion team. Maybe there is a data modeling team. Maybe there's a machine learning team. Maybe there's a front-end serving team. And all of these teams have to coordinate with each other to ensure that the pipelines are running reliably. So to Unravel, we talked to more than 200 companies to understand how they manage their data pipelines. And we got a lot of interesting responses. There were users who told us that their pipelines sometimes can fail or become slow. And unfortunately, such problems are only detected after they have happened. For instance, after the pipeline has missed an SLA. And sometimes fixing these problems can take days, if not weeks. Some other users told us that as more and more these data pipelines are becoming mission critical, they have strict SLAs, and misses of SLAs can actually involve penalties. And in this data pipeline world, we got a lot of responses that clearly illustrate the gap that has always existed between the dev teams and the ops teams, where the dev teams finger point as the ops teams and say, hey, the platform is not stable and my pipeline is slow, where the ops team often is pretty frustrated. And we even heard responses like, do these devs ever test their pipelines? As pipelines start to increase in companies, we saw certain users complaining about the challenge of orchestrating multiple pipelines, right? Be it in the form of dependencies, or more commonly, the lack of coordination scheduling these pipelines, which can end up leading to situations where the cluster is all jammed up because all pipelines are kind of scheduled at the same time, or the cluster on the cloud setting auto scales to become very, very large unnecessarily. And as you know, on the cloud, if things auto scale and become larger, it's not the case that they might actually downscale at that same pace. We heard a lot of complaints from users saying either these pipelines are not generating the right data, or sometimes they're not even getting the right data to work with. And detecting these problems can be hard. A lot of enterprises are trying to modernize their pipelines, for instance, migrate them to the cloud. We heard a lot of stories about either this process taking a long time or sometimes just resulting in failures. And there were a lot of interesting use cases around modernizing the pipelines in terms of processes, such as bringing CI/CD or ensuring that all of these pipelines are cost efficient. As we got all of these responses, we tried to aggregate them together to understand the common patterns. And one thing emerged very, very clearly: the fact that a lot of these responses have to do with the people, the personas that are involved with these pipelines. And what emerged is that each persona was talking about the challenges they face on a day-to-day basis for their roles and responsibilities. For example, a data engineer who is responsible for a particular pipeline, and that's where she might be responsible for fixing the problems in the pipeline very, very quickly. Right? Or a CDO who's responsible for migrating or modernizing these pipelines. And once we understood the personas and their needs and the kind of challenges they face, we made an attempt to organize all of this information in a more actionable way. And that led us to create a data pipeline maturity scale. The scale goes left to right. There are different phases in maturity. The lowest is where teams who own pipelines do not have a good methodology to troubleshoot problems in these pipelines very quickly. And this results in both detection and fixing of problems taking days, if not weeks. As we go further on the maturity scale, maybe detecting and fixing the problems once they are detected could be done in days, but always the detection happens after the fact. That is, after the fire has started. And further along the scale, some teams and pipelines at least have one single place where they're able to bring all the telemetry data to troubleshoot problems with these pipelines. Now, further along the scale comes in more automation. For example, automated detection of problems before they happen. And further automation and further maturity can result in root causes of problems also getting detected automatically, such that the time to fix and get a pipeline back up and running, if indeed there is a problem, is small. Well, of course, the holy grail in all of this is the concept of self-healing data pipelines, where the pipeline intrinsically is able to detect these problems and fix them. So where are most enterprises in this maturity scale? As we dissected the data and tried to understand, it emerged that most of us are actually at the lower end of the spectrum today. Of course, not everyone. We definitely saw interesting pipelines where either the data to detect problems was in a single place or the problems were getting detected proactively. But the majority are at the lower end, where detection of problems happens after the fact, and fixing of these problems can take days, if not weeks. And this is where I have a dirty little secret to share. In fact, as we introspected how we are solving our own problems at Unravel, an interesting pattern emerged. First and foremost, to those of you who are not familiar with Unravel, the product, we capture logs, metrics, traces, events, configuration information, metadata from a variety of different data platforms. And the data product we built on top of this data does interesting things like it detect when a Spark application is slow and tell you how to fix it, or create rich dashboards that can pinpoint who's using how much of resources and how much cost are they incurring, and then help you slice and dice that to the level of individual departments or projects within departments, identify inefficiencies in that usage and help you fix that, or migrate your data pipelines to the cloud. And the way in which we do that is also fairly standard. So the Unravel product itself is the data pipeline where all of these rich sources of data, ranging from the structured metrics to unstructured logs, goes through pretty much all the phases of a data pipeline that any other enterprise has. We don't have some of the phases today, like we don't have a warehouse and we don't have a feature store yet, but almost all the other phases of the pipeline is there in the Unravel product. And so naturally, the question emerged, hey, where are we in the data pipeline maturity scale? And it was a surprise to some of us and not a surprise to some others that actually we were here, where we would also detect problems with our pipelines a lot of time after the fact. And sometimes fixing these problems could also take us days to weeks. And that's when we decided we should have a mission to make pipeline data ops better. Of course, that will serve us and make our own pipeline data ops better, but we can use this entire process to make pipeline data ops and our learnings made available to everyone. So all of us can actually become more mature in the day-to-day pipeline management. I'd like to share some of our results and findings with you. And the way I want to do it, I want to actually show it to you in action. So I'm going to do a quick demo. And for the purpose of the demo, I've chosen a new data stack. And these are the components of my data stack. So my data stack is actually running multiple data pipelines. And the components there are Databricks, where advanced analytics is being done with Spark. The storage itself is on a data lake that resides on Azure, on the Azure Data Lake Storage, ADLS. Orchestration of all of the tasks for ingestion and for processing is done via Airflow. And a lot of rich ELT and the transformations accompanying them are done using DBT, the data build tool. And in addition to these components of the pipeline itself, in our demo stack, we have 3 tools. We use Great Expectations to validate data and understand data quality problems before they become fires. We use Slack for alerting and team communication. And last but not the least, Unravel for end-to-end observability of these data pipelines. And what I'll do in the demo, I want to take you through 3 scenarios, all of them involving data pipelines. In the first scenario, I'll show you how you can proactively detect that a performance SLA of a pipeline is in danger of being missed. Then I'll show another example where a data pipeline that was pretty healthy and reliable suddenly started to take more cost to run, or what is called a cost overrun problem. And my third scenario will involve a pipeline that's actually in danger of breaking due to a data quality problem. In fact, a lot of the time, it's not just the issue of this one pipeline breaking, but that can cause multiple other dependent pipelines to break. So let's see these things in action. So what you see here is Slack and a channel where alerts from Unravel are coming in. As you can see, there are a few alerts that have come in already. Let's see the very first alert. It says a data pipeline is in danger of missing an SLA. So the run of a pipeline reporting insights hourly has been detected to be significantly slower than the baseline. So one click brings me into a view, what we call a pipeline observer view. So as you can see, this is showing a run, the most recent run of the reporting insights hourly pipeline. The status shows that the pipeline is delayed. And what you see in these tables here are information about the baseline key performance indicators compared with the performance indicators of the current run of this data pipeline. The duration is shown in milliseconds. So the baseline duration of this particular pipeline, it finishes within 1 minute. But the most recent run is taking more than 5 minutes. And that's the change of performance that was detected and what fired this alert. So it's great to see in one place, like, what happened to this pipeline. But immediately the question becomes why? Why is this pipeline running slower today? Right? And a lot of the time, that can be trying to detect a needle in a haystack. But here in this pipeline observer view, there's a root cause analysis service that runs concurrently. And the service is called Sherlock. Right? No prize for guessing why. So Sherlock Insight has come in here and is saying that a particular application that was running as part of this particular pipeline has been significantly slower and had a big delay. And it tells us, to check here to understand why. Let's do that. So in one click, that takes us to holistic cluster view of what is going on in the cluster. And immediately I can spot the problem. Here is our reports insights hourly pipeline that's stuck in an accepted state when some other ad hoc application got submitted to the same queue and is consuming a large amount of resources and starving out our pipeline. Very quickly, we can understand what happened, right? And this is commonly referred to as rogue applications in the industry. This rogue BI app is causing my pipeline to get into danger of missing its SLA. Notice how very quickly we were able to go from understanding the exact problem to understanding why it happened. So that was my first demo scenario of showing you how, from an end-to-end fashion, we can quickly troubleshoot why a pipeline is in danger of missing an SLA. Let's consider two more interesting examples. Of course, like today, cost, especially as more and more pipelines are running on the cloud, is top of mind for most CDOs. So here I've got an alert that's saying that my data pipeline, namely the Job Insight Aggregate version 4, its cost has significantly increased from the baseline. Let's check out what's going on. One click. Once again, I'm in the corresponding view of that pipeline. And as you can see from a status here, it's delayed and it's also having a cost overrun. Once again, really quickly comparing with the baselines, you see this entry, the cost KPI. The cost is in cents. So this pipeline was taking around $2.50 in the past, but today it's already taking, it's taking $25 in the past, but today it's already taking $122. So almost a 5x increase, right? And if you just scroll down and see, the cost becomes pretty clear. So what each of these bars represent are runs of components of the pipeline. And as you can see, it used to have 6 components, but somebody changed the code. And now there are 10 components. And these newer components seem to be taking much larger cost. Once again, being able to quickly understand what the cost of the problem is, and then we can reach out to the user who owns this pipeline. Hari. Let's take one more interesting scenario. So this is a very top of mind item for a lot of data product owners today. Pipeline having data quality issues. So the Unleash Spot pipeline has data quality issues in the customer table. Let's take a quick look. So this is the Unleash Spot pipeline, which actually is on time and its cost is looking good, but is having data quality issues. So right here in the insight, and this insight is coming from the Great Expectations tool. This is a tool where you can define assertions on data, just like you define assertions in your code and what is expected. In a similar fashion, you can define assertions on data, what Great Expectations calls an expectation. And as it's being shown here, the as part of the pipeline, in this stage of the pipeline, 6 expectations were defined. 5 of them successfully validated, but 1 did not. And that validation failed on the customer table. And very specifically, that assertion was saying that the number of records returned should be between 1 and 10,000, but the number of records returned was almost double of that. Right? And very quickly, not only can this user understand where the problem happened, but also quickly understand which other pipelines might be affected. So these were the 3 quick demo scenarios: the danger of missing SLA, the cost overrun problem, and data quality problem. Let me very quickly tell you about the solution itself. So overall, the architecture of the pipeline observer that you saw, it uses a microservices-based design. The first part of building the pipeline observer is, of course, stitching together the entire pipeline across all these different components, as we saw: Databricks, Airflow, dbt, and the ADLS data store. And this might be a simple pipeline. A lot of real life pipelines, as you'll see in multiple talks throughout the conference, can be even more complex. But once we have stitched together the pipeline, the information of the pipeline itself goes into a real-time data store, from where other services, such as the baselining service, builds baselines as well as can detect anomalies based on the baseline, or a root cause analysis service can pull this information from the real-time store and figure out what is the root cause of the problem, like a data quality issue or a row gap and whatnot. And all of this information is brought together from an end-to-end fashion in the pipeline observer UI. So you get a end-to-end pipeline observability tool by combining all of these microservices together. So some key takeaways. As you saw, based on all the analysis that we had done, studying more than 200 enterprises, it's become clear that in terms of a data pipeline maturity scale, a lot of us are towards the lower end of the spectrum today. But by applying Dataops principles and using the right tooling, it's very possible for all of us to start becoming more mature and getting towards the higher end of the spectrum. In fact, the holy grail still remains to make our pipeline self-healing, and we might get to that someday, hopefully pretty soon. Thank you.